Okay, in this video, we're going to take a look at determining the probability of events that are separated by the word or. In our last section, we took a look at events that are separated by the word and. So we're going to look at calculating probabilities in this video using what's known as the addition rule. So in the last section, we examined probabilities that focused on the word and. The word and in probability means multiply the probabilities. In this section, though, we're going to focus on the word or, which in probability world means we're going to add the probabilities together. So in example 1, a fair die is rolled. What's the probability of rolling a 4 or a 5? Well, the number of outcomes in our sample space for rolling a die is 6. We have the numbers 1 through 6. And we want a 4 or a 5 to happen, and that can happen in two possible ways. Either roll a 4, which is one way, or a 5, which is another, for a total of two ways. So our probability of rolling a 4 or a 5 on a fair die is 2 out of 6, which reduces to 1/3. So in that example, the events rolling a 4 and rolling a 5 are mutually exclusive. In other words, they cannot happen at the same time. So to find the or probability for two mutually exclusive events, we can use the addition rule, where if our two events are labeled A and B, then the probability of event A or event B occurring is the probability of event A occurring plus the probability of event B occurring. In terms of a Venn diagram, the probability of A or B is both circles shaded together. So circle A, circle B, and the overlap as well. In our last section, we saw with the probability of A and B, with and, it was only this region that the circles have in common, only the overlap. With or, it's one or the other, or both. So example 2, table below lists the types and numbers of cars sold at Lemon Autos along with their ages. Find each probability. So part A, if a car is randomly selected, so out of the 200 possible cars, what is the probability that the car is either 0 to 2 years old or over 10 years old? Well, the probability that's between 0 and 2 years or over 10 years is going to be the probability that the car is between 0 and 2 years old plus the probability that the car is over 10 years old. Well, there's 72 cars that are between 0 and 2 years old out of the 200, and then there are 61 cars that are over 10 years old out of the 200. So 72 and 61 out of 200 is 133 out of 200. Part B, if a car is randomly selected, what is the probability that the car is 3 to 5 years old or a domestic car? So we want to know the probability that the car is 3 to 5 years old out of the whole lot, and then also the probability that it is a domestic car. So for the 3 to 5, we have 44 cars are 3 to 5 years old out of the 200 again. And then for domestic, we have 100 cars out of the 200 are domestic. So our probability for selecting a car that's 3 to 5 years old or a domestic car is 144 out of 200, which is 18/25. Or is it? Well, we have 23 cars that are counted twice. These 23 domestic cars that are between 3 to 5 years old, once for being in the 3 to 5 column, and a second time for being a domestic car. So these 23 cars that are 3 to 5 years old and domestic cars were counted twice in that last calculation. And if it's counted twice, we only want it to count once, so we're going to need to subtract the 23 cars that are counted twice from our original total of 144. So the actual probability that a car is 3 to 5 years old or domestic is 121 out of 200. And that leads us to what's known as the general addition rule, where the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And we didn't see this in the last, in our first example with the rolling the fair die, or with the 0 to 2 and over 10, because if A and B are mutually exclusive, then this probability is 0. So that's where we saw rolling a 4 or rolling a 5. You can't roll 4 and a 5 at the same time. So for a Venn diagram with our general addition rule, we have our first event A, like the car is 3 to 5 years old. we have our second event B. Notice we get this like purplish area in the overlap. We don't want to count that twice. So it was first time it was this salmon color for A, and then the second time it was this blue color for B. This overlap here is counted twice. We don't want to count it twice, so we have to take out one of those countings. So now it's this overlap region in the middle is only counted once. So for example 2b, if we wanted to fill out a Venn diagram, first let's fill out the number of cars that are domestic cars and 3 to 5 years old. So out of the 44 total cars, 23 of them are also domestic, which makes 21 of them imported. And then for domestic, we have 23 that are between 3 to 5 years old, and then the rest of them are other 77 of those domestic cars are a different age. So if we take 23, 21, and 77, we get our 121 out of 200. So if you're going to use Venn diagrams, I recommend filling in the intersection first. All right, example 3. If a single card is drawn from a standard deck, what is the probability of selecting a 3 or a club? So the number of 3s, we have 4 of them. We have a 3 of clubs, hearts, diamonds, and spades. We have 13 total clubs, but we have 1 that is in both groups, the 3 and a clubs. So the 3 of clubs card would be counted twice, once for being a 3 and a second time for being a club. So the probability of a 3 or a club is the probability of a 3 plus the probability of a club minus the probability of a 3 and a club. Well, we have 4 out of 52 plus 13 out of 52, but then the 3 of clubs card is getting counted twice, so we're going to take out that one instance so it's not counted twice, and we get 16 out of 52, which is 4/13. Part B, what is the probability of drawing a face card or a red card? So number of face cards, there's 12. Jack, queen, and king, and then each of the 4 suits. We have 26 red cards. All of the hearts and diamonds are considered red cards. However, the jack, queen, and king of hearts and diamonds are counted twice. So we have 6 cards that are counted twice. The jack of hearts, the jack of diamonds, the queen of hearts, the queen of diamonds, and the king of hearts and the king of diamonds are in each of these 2 groups, so we don't want to count them twice. So adding the probability of a face card, 12 over 52, plus the probability of a red card, 26 out of 52, and subtracting the cards that are counted twice, the 6 red face cards, we get 32 out of 52, which reduces to 8/13. So if you have any ones that are counted twice for or, make sure you subtract out the instances where they're counted twice. All right, that about does it for this video. Thank you for watching. I'll see you next time.